close parentheses. So my answer now is 16.043. And I'm not going to round until I have to, until they make me. So again, I'm going to write this down. It's going to be 16.043 grams. Wunderbar. Now what? Now I'm going to do exactly the same thing down below for oxygen. So oxygen, I'm going to change that into moles of O2. So 1 mole of O2 is how many grams? Again, go back to ptable.com. Pow. Oxygen right there, 15.99 times 2. 15.999 times 2 is 31.998. 998. 31.998. All right. So now we're going somewhere because now we've got our grams of canceled out. That's grams of O2. I could have written O2 here, but I don't need to. And these are going to cross off. Now we're in terms of moles of CH4 and moles of O2. So we've changed the initial amounts into the moles of those molecules. So basically we're saying, okay, with that many grams, how many of the CH4s can we make? And we're going to use moles as our unit here. And how many grams, or given that many grams of O2, how many molecules is that really of O2? Then we're going to change that number, since we know that these ratios here, there's 1 CH4 for every 1 CO2. So I'm going to use a little molar ratio here. That's what they call these things. So for 1 mole of CH4, and I got that 1 from right here, there's 1 mole of CH4. There is how many moles of CO2? There's 1 mole of CO2. So with this, we say, okay, how many CH4s can we make, or how many moles of CH4s can we make with that many grams? And then we see how many moles of CO2 there are for every mole of CH4 in this reaction up here. In this way, you can figure out how many moles of CO2 you can make. So I'll just leave the units here, moles of CO2. All right, so I'm going to cross off those units, and then I'm going to put the answer down here. So I'm going to calculate this out. So I'm going to take 2.31 and I'm going to divide by 16.043 because multiplying by 1 over 16.043 is the same thing as taking 2.31 dividing by 16.043. And I'm going to get something like 0.1439880322. And now since I multiply this by this, which is 1 over 1, my final answer is just going to be the same as what I got for just before. So it's 0.143, and I'm not going to round it yet. 3988. I'm just going to stop right there just because I know that's way past the number of sig figs I need. Okay. Now I'm going to do the same process over here, except now my molar ratios might be a little different because you've got the 2 right here. Check that at 2 out. So we've got, in this case, we've gone from grams into moles of O2 molecules. So now we're going to see how many O2 molecules there are for every CO2. There are 2, as you can see, 2 moles of O2 for every 1 mole of CO2. So now these cross off here. We're all in business. This is going to be moles of CO2. And that's great because now we can compare this answer, whatever it's going to be, to this answer up here and see which one will make more and which one will make less of CO2. So let's calculate this out. Let's say 2.42 divided by 31.998. Okay, I'm going to hit enter. And now I'm going to multiply, or I guess I could divide that answer by 2 if I wanted to. So I'm going to divide by 2. And I get 0.0378 148 486 blah blah blah. It keeps on going. Okay, so which one of these numbers is bigger? I hope you say this. I hope you say this. It's got 0.037 instead of 0.1. Okay, so this is less over here. So that means this amount of O2 will produce less product than this amount of CH4. It produces more product. So that means that this, given these starting conditions right here, the limiting reactant, this is our limiting reactant. Okay? So in a problem, I expect you to be able to show all of this work. Okay? This shows you that you've made less product over here, so that gives you the evidence that this is a limiting reactant. But the answer is that the O2 is the limiting reactant. The 2.42 grams of O2, that is the limiting reactant. That limits your reaction. All right? So this will run out first. As soon as this is gone, this 2.42 grams of O2, you can think of it as like fuel. That is fuel. As soon as that's gone, this reaction stops. Okay, so the maximum amount of product you can make given these starting conditions right here, even though you've got 2.31 grams of CH4, you can't use all of that because you're going to run out of O2 here. And once you run out of O2, the CH4 can't combine with O2 anymore. So this reaction won't go forward. Okay, so this over here, this is the amount of product you can make. And soon we're going to give that a name. We're going to call that theoretical yield, but that's coming. Right now, you don't need to know that. You just need to know that this is the limiting reactant because it gives you a smaller number over here of product. Okay, that's it. Good luck. Bye.